You know, the universe seems to run on some pretty strict rules defining what can and can't happen. And right at the heart of it all, there's this one number, c, the speed of light.
That's right. And we got some great source material asking, well, not just what this speed limit is, but why it even has to exist. Why is it so fundamental?
Exactly. So today, let's really dig into Einstein's cosmic speed limit. What is it, and why is it apparently tied so tightly to cause and effect, to, well, reality itself?
Well, the first thing, and the sources nail this, is maybe we shouldn't just call it the speed of light.
Ah, right. They suggested thinking of it as the invariant velocity or the special speed. What does that shift in thinking get us?
It gets us to the core idea. This speed, c, it's measured as the exact same value by everyone, no matter how fast they're moving or in what direction. That invariance, that's the linchpin.
So it's not really about light specifically. Light just happens to travel at this speed.
Precisely. Light travels at c because it's massless. Gravity waves also travel at c. It's the universe's ultimate speed limit. And crucially, anything with mass, well, it just can't reach it. Special relativity makes that clear.
Oh, and why can't massive things reach it? This is where that famous equation comes in, right? E equals mc squared.
Exactly. It boils down to the equivalence of mass and energy. As you push something, you give it kinetic energy. But according to relativity, that added energy actually increases its effective mass, its inertia.
So the faster you go, the heavier you get, in a way.
In a very real way, yes. And the closer you get to c, the more energy you need for the next tiny bit of acceleration, because the mass just keeps climbing. To actually reach c, you'd need an infinite amount of energy.
Infinite energy. Okay, so that's a pretty solid physical barrier. You just can't do it.
It's an insurmountable wall built into the physics, yes.
But the sources hinted it's deeper than just energy. They linked it to logic, to causality. Why is c also the absolute speed limit for information, not just objects?
Right. Because if you zoom out, the whole structure of spacetime itself, what physicists call Minkowski space, basically the mathematical map combining space and time, it's fundamentally built to protect causality.
Protect causality, meaning cause has to come before effect. Always.
Always. That's the bedrock of logic, of how we experience reality unfolding. No effect should precede its cause.
So what's the gotcha moment? What happens mathematically or logically if we imagine information could somehow beat c?
Well, this is where relativity gets really interesting. If a signal travels faster than light, FTL, then because observers moving relative to each other experience time and space differently, there now slices through space-time at different angles, essentially.
Okay.
It becomes possible to set up a scenario where that FTL signal can be used to send a message back to its starting point before it was even sent out in the first place.
Whoa, hang on. So you're saying a faster than light communication doesn't just mean getting messages quickly. It literally means time travel paradoxes become possible, like the grandfather paradox.
Mathematically guaranteed. It's not just sci-fi fodder. If FTL information transfer is possible, you can break causality. You could, in theory, send information back to prevent your own message from being sent. A direct contradiction.
So the speed limit c isn't just a physical limitation, it's like the universe's built-in firewall against logical paradoxes.
That's a great way to put it. It preserves the logical sequence of events. It locks down the past relative to the future for all observers, preventing those causal loops.
Okay, but then what about those things people bring up, like galaxies far away moving faster than light? Or quantum entanglement, that spooky action at a distance?
Good questions and important distinctions. Those distant galaxies appear to recede faster than c because the fabric of space between us and them is expanding rapidly. They aren't actually traveling through space faster than light locally.
So it's an expansion effect, not local motion violating the limit.
Correct. Locally, near the galaxy itself, the speed limit holds perfectly fine. And with entanglement, yes, measurements on entangled particles are instantly correlated no matter the distance.
Seems faster than light.
It seems like it, but there's a crucial theorem, the no communication theorem. It proves you absolutely cannot use that instant correlation to send a deliberate, controllable message, what we call classical information, faster than light. You can't use entanglement to, say, text someone instantly across the galaxy.
So even the spooky stuff respects causality in the end.
Causality remains safe. No information gets transmitted, FTL.
So let's wrap this up. What's the big takeaway for you listening? This speed, c, it's not just some random number for how fast light travels.
No, it's far more profound. It's a fundamental constant woven into the very structure of space-time, acting as the ultimate guardian of cause and effect. It ensures reality unfolds in a logically consistent way.
It keeps the past in the past and prevents the universe from descending into paradox.
Exactly. It's the constant that makes a logical sequence of events, and therefore our experience of reality, possible at all.
This deep dive was sponsored by embersilk.com. If you're looking into AI education or integration, check out embersilk.com.
And if you found this look into the universe's rules interesting, please do subscribe to the deep dive and maybe leave us a 5-star review. It really does help get these discussions out there.